Now that the head tube joints are all cleaned up, let's put the frame back on the table and just check to see how close we are to our drawing. We'll line up the down tube and the head tube first. It's a little harder to line up the head tube now because there's that large fillet in the back, so you sort of have to jump to the front of the head tube now, but it looks pretty good. Next, we're going to ream and face the head tube, and one thing that has to be done is you need to clean out all that grit that was left from the sandpaper, because that stuff will really dull your tools. You may even want to use a circular wire brush to go in here and remove this grit, but make sure that's absolutely clean. We're going to ream and face the head tube, and we're going to start by doing the worst end first. The worst end would be the top, because that's the one we cut off with the bandsaw. The bottom of the head tube had a factory end on it, so it's probably a little bit straighter. So we always do the worst end first. Make sure and use cutting oil on the cutters. Fairly generous amount. Notice I have the head tube in a horizontal position. If you put it in a horizontal position, your cutting oil won't run off as much. If you put it in a vertical position, the cutting oil will immediately run down the head tube, and you won't have a sufficient amount of oil on the teeth. This is a VAR reamer facer. The VAR reamer facer is a very nice one because it's very adaptable to the different sizes on the market. This particular head tube is an 1.125" steering column, and that's pretty much the standard for mountain bikes these days. The standard for road bikes is for the most part 1 inch. There are some more road bikes these days being built with 1.125". There is an 1.25" size. The 1.25" size is sometimes used on tandems and was popular on mountain bikes back in the early 90s, late 80s. However, the 1.25" size is kind of overkill. The VAR tool is very handy because all 3 size cutters fit on their tool, so it makes it a very adaptable tool. Campagnolo and Cobra also have an additional cutter that you can purchase. It's a Cobra cutter, and so you can do either 1 inch head tubes, 1 inch diameter steering columns. You can do the head tubes for those with Campagnolo or Cobra. You can do an 1.125" with the Cobra cutter, which fits onto the Campagnolo or the Cobra tool. And then there was a Fisher cutter that may still be available. The Fisher cutter was for 1.25", and that will also fit on either the Campagnolo or the Cobra head tube reamer facer. Notice we're taking kind of a heavy cut here. Just the nature of the cutter requires that we have a little bit more pressure on that threaded area at the bottom of the tool than we would on a bottom bracket facer. All right, we're gonna. It's easy to pull that out and inspect. You want to be clean all the way around. And if it's shiny all the way around, you can flip it over and do the other end. If it's not shiny all the way around, reassemble everything and continue to cut until you've got a shiny surface all the way around the head tube. When you finish the first half of the head tube, then flip it over and cut the other half. Just cut it until you have it smooth and shiny all the way around. Don't use the tool to cut off major amounts of material. Just cut until it's just clean and faced. At the end of the cut, you can back off on the spring pressure for a finishing cut. Well, now that our front triangle is completed, we can go on and start on our fork. Here I'm setting up the fork building fixture, and basically this is very similar to what we did on the table with the tubing heights above the table. I'm measuring to the top side of the steering column as it's held in the V-block here, and then I'm subtracting the radius of the steering column so I can find a center point of that steering column above the plate of the fixture. And then over here I'm going to measure to the top of the dummy axle and subtract the radius of that dummy axle, and then that'll give me the height of the dummy axle above the plate of the fixture. And the difference between the two readings is your fork rake. So you set these, basically you find your steering column height above the fixture, and then you add your fork rake, and then you use that figure to locate the top of your dummy axle here. There's a nice diagram of this process in my book, and it explains it quite well. You can see here we're going to be making a set of straight-bladed forks. Straight-bladed forks are about the easiest forks that you can make in the bicycle industry. We do have to do a modification here, and that is that these are cut at the factory as if they were going to be raked. And so the angle of this miter right here is at the wrong angle. It has to be modified for about a 5-degree discrepancy. And that's what we're doing. We're taking a little bit out of one side and we're taking a little bit out of the opposite side there to twist this angle roughly 4 or 5 degrees. That's what would be necessary for a straight-bladed fork. And then we're going to go back and see how it fits. We've still got some gaps, so we're going to go back to the vise and get this fine-tuned so it fits nicely against the steering column. This could be done on a milling machine. If you're going to do it on a milling machine, you should plan on doing probably 20 sets at once. If you're doing just fork blades one up, it's easier to do it by hand. This will take several fittings to get this just right. And then, of course, you'll want to go and do the other one, exactly the opposite of this one, and get them so they all fit with the minimum of light gaps between the pieces. And of course, as with the other joints, we don't want to have those very thin points of the miter sticking up because they'll vaporize under high heat. So we're going to trim those off, flatten those out a little bit, and deburr this so that those burrs don't heat up as well. Now we've got the second side done, and we're going to check to see what kind of a fit we have here. Checking for light gaps, and it looks pretty good. Nice modification job. Another thing we have to check for is we need to check to see if the dropouts are lying flat against the ends of the dummy axle. And in this case, they're not quite flat, so we're going to give this a little bit of a tweak and get that dropout to lie flat against the end of the dummy axle. Another little bit of a tweak. You don't want to overdo it. It's best to do it a little bit at a time. And then when we get this first side done, then we'll go on and get the other side so that one lies flat. All right, we have things pretty well snugged up in place. And of course, we want to keep those blades tight against the steering column. So a real handy tool to do that is just an old toe clip strap. And pull that nice and tight so those blades are tight up against that steering column. And now we're going to just check here to make sure that we don't have any twist in the unicrown area. So we're going to take a universal surface gauge and just do a little scratch there to see what kind of a height we have on each side. And if we have a problem there, you remember these are plug-in dropouts. If we have a problem there, we'll warm up the dropout joint and we'll twist the dropout a little bit to get rid of that problem. Here we're putting on our Welco number 17 flux and put on a generous amount. Make sure it's all over the joint, so go ahead and put it on the back side as well. If you're the type that feels that you need extra flux, it's going to fall on the floor and you don't have that much control over it, put a couple extra gobs about 4 or 5 centimeters away from the joint so that you can scoop them up and bring them back into the joint. We're going to tack this in the fixture, and we'll put a couple fairly large tacks on the front, and then we'll flip it over and we'll put a couple fairly large tacks on the back side. The crown is probably about, or the steering column is probably about twice as thick as the blades are, so you might want to favor the steering column a little bit. This fixture, by the way, can be built from the set of plans for fixtures that are in the back of my book. There are very detailed drawings in the back of my book that show you exactly what sizes, exactly what material to use, and exactly how to cut the pieces for this to shape. It's nice to have a hole in your fork jig so that you can do work on the back side of the crown without having to worry about that back plate being in your way. Here the fork is held in the park stand. Notice I have a fancy little clamping assembly. I like to use that. It keeps my vinyl on my park arm from melting during brazing. We're going to start by building a fillet along the top side of the joint. This is an obtuse area, and an obtuse angle doesn't have quite as much pulling power as an acute area would. We're going to do a little splice here so we don't waste our welding or our brazing rod. So what we're going to do here is we're going to build around the top side. Then we're going to completely finish the front and the back. And we won't do the underside of the crown, or the unicrown, I should say. We won't do the underside of the unicrown until the very last, because that area down there would be considered an acute angle or an acute area, and it'll have a lot of pulling power down there, and it'll pull the dropouts close together again. One thing that's a good idea is to put a threaded rod between the dropouts before finishing the fork. And you could even jack the dropouts out maybe to 105 millimeters or so, because there will be a tendency for the dropouts to want to pull together. Notice that I move this around a lot. There are a lot of different contours in a unicrown fork, and you have to keep your work area on top when you're fillet brazing. And to do that, you need to flip this piece many times. You can see I've flipped it 2 or 3 times just in the last minute or so. We have the front and the back pretty well done, and the top of the joint is pretty well done. So now we're going to flip it up, and we're going to do the underside. This is the part of the crown, the part of the fillet that has a lot of pulling power, so we saved this for the very last. They're kind of small fillets down here, but because of the fact that they are an acute type angle, they have much more pulling power than you would really realize. Goes kind of fast under here because they are kind of small. And these 2 little webs that we're building right now will then become like little dams, and when we start working on the rest of it right about now, we'll use those little webs and they'll keep our brass from falling on the floor. So we fill up in that area right above those little webs. You can see the dummy axle that I put between the dropouts to preserve the spacing on this fork. As I said earlier, there will be a tendency for those dropouts to pull together possibly as much as a centimeter after cooling. So I'm propping them apart with a dummy axle. Now that the fork has had plenty of time to cool, and we've soaked the flux off in water, we're going to check out the alignment and cold set it on the table here. We have it mounted sideways, and we're going to take a reading on the lower dropout and with the universal surface gauge. Then we can loosen it and flip it and square it up with the machinist square. And then we can take another reading to see how the 2 readings match. Then we can adjust it or cold set it so that the 2 readings match each other. in the plans for fixtures, there is a device called a dropout center alignment gauge, and that allows you to inspect the fork quickly for centering. This is just another way to do it, this flip-flop routine. Nice thing about flip-flop is it doubles your error, so error is easier to see when you flip-flop. We can also do it by taking a measurement on the outside of a dropout and flip-flopping the fork and taking a measurement on the outside of the other one. And as I mentioned earlier, the dropouts more than likely will pull together as these have, and so you take the fork and frame straightening tool and pull up a little bit on that until you get the reading where you want. Also, that bottom dropout is going to come up a little bit, so you may have to flip-flop again and take your reading on the other side and bend up on the other side as well. It's a trial and error sort of system that you have to do over and over. Here we're checking the dropout spacing. We're going to try for 100 millimeters. Let's grab a frame building wheel and put it in the fork to see how the wheel sits from side to side. Unicrown forks are really nice when it comes to how they are finished up. This one looks really good. Sits evenly from one side to the other after it's been trued in the on the alignment table. We're going to finish the dropout joints, clean off any spatter that we have there. I'm using a Nicholson 6-inch flat file to do this, and I'm keeping the file tangent to the tube, and I keep rotating it around so I don't create any flat spots. Incidentally, if the wheel were to sit one side or the other too much, we would probably have to warm up one of the dropouts and pull it out slightly, or possibly remove one of the dropouts and shave a little bit off the end of the fork blade and then re-braze the dropout back in place. There is pretty extensive coverage in my book on pulling dropouts to get your wheel to sit center. So if you want to check that in my book, just look it up in the index, pulling dropouts, or look it up under dropouts, pulling front or pulling rear. This is pretty much just cosmetic cleanup at this point. And of course, when we finish this filing, we'll do some sanding. We'll finish it out with emery cloth strips. And here we are with the emery cloth strips. We're using a 100 grit, and underneath the thumb, holding it underneath the thumb really gives you good control over the contour that you're trying to clean up. You might want to, if your skin isn't quite tough enough, you might want to put some flexible fabric band-aids on your thumb or on your finger to keep from cutting yourself. Now we start with the tedious cleanup of the actual fillet brazing around the unicrown area. The files that I really like to use for this particular application are the 10-inch round file, which I'm using right now, and I like to use a 6-inch half-round file for this. You just have to go around the whole area and take down all the high spots. Some people like to do this with a die grinder. One thing that happens with a die grinder is people go for the rough-looking areas, and so they see a little bit of a rough area and they buzz it with the die grinder. And when you do that kind of thing with a die grinder, basically you're going after the low spots, which is exactly the opposite of what you want to do. You want to be going after the high spots. So I've seen people in the past that when you give them a die grinder and let them do this, it ends up being just as bumpy when they get done with the die grinder as it was before they even touched anything. However, the files do a very good job of flattening things out and just kind of cleaning off all the high spots, which is exactly what you want to do. Very careful while you're doing this so that you don't take too much steel off. We're really trying to remove brass here. If you start removing steel, you're going to have undercutting, and the undercutting may not look too bad until it gets painted. Boy, when you hit that with a coat of primer and there's undercutting there, it really stands out. So we're going after brass here, not steel. Be very careful not to hit the steel, and especially if you're using a die grinder for doing any of this, stay away from the steel. After you get done cleaning things up with the file, if you're lucky, you have a Dynafile, and you can just grab that Dynafile and start sanding away with that. Again, the Dynafile is something that really eats metal really fast, and you can undercut with the Dynafile very quickly. Use a very light touch with the Dynafile. When I'm doing this sanding, I'm pressing very lightly on the brass, and as I leave the brass, I lift up with the tool so that I'm putting almost no pressure at all on the steel. As I mentioned earlier in the video, there are some cheaper knockoffs of the Dynafile, which also do a really nice job. I particularly like the Dynafile, and I do prefer it. The Dynafile will go through a lot of belts when you're building a frame. You can expect to go through 6 to 8 60 grit or 80 grit belts in building a single frame. If you're building tandems, you can figure on going through 15 plus. The belt just after a while wears out. All the high spots of the belt will have little shiny pieces of brass. And when those little shiny pieces of brass are sticking in the belt, it's just not cutting anymore, so you have to replace the belt. Replacing a belt is really fast with a Dynafile, very easy to do. One thing you have to be careful of with the Dynafile is that area right behind the spinning head. That area cuts really fast, so be careful with that particular area and go very lightly with it. You can get into some really amazingly difficult places to get at with the Dynafile. You notice when you hit the steel, we get sparks. If you're on brass, no sparks. Hit the steel, you're getting sparks. The object is get as few sparks as possible. After I finish up with the Dynafile, I always get my emery cloth 1-inch wide strips, and I do a hand sanding after the Dynafile. The Dynafile will leave something that's almost like facets, and by running the hand sanding over this like I'm doing here, you get rid of those facets and things smooth out really nicely. So take a few extra minutes and just do some hand sanding over the top of the Dynafile work. And we can do a little bit of shoe shining to kind of finally tie things together here. Just sand those edges between the metal that hasn't been touched and the metal that's been Dynafiled and sanded. And when we finally get that all done, we'll have a very nicely finished, shiny looking fork. And here we go. Nice finished looking piece. Tubes in the frame need 2 air expansion holes. As you recall, we had 1 air expansion hole in the steering column at the top that vents into the top of the blades. This particular fork, it's easiest just to save these vent holes at the bottom for the very last. And so what I'm doing is I'm just drilling a hole straight down next to the dropout at a slight angle. Now, one thing that we're going to have to do to this Unicrown fork is it does not have a crown race press fit area yet, and so we're going to have to file a little bit of a shoulder right here at the top of the fillet on the Unicrown. And so we're going to file this little shoulder here so that the fork crown race will drop down. we have to go back to the drawing to see just how thick we want this fork to be. Probably more than likely an 1.125" steering column with unicrown blades. We'll want a fork thickness of about, or a fork crown thickness of about 5 centimeters. And so this is kind of a, you have to sort of carefully juggle how much you're removing from this fillet to make this shoulder with how thick your fork crown race is, so that you end up with the amount of fork crown thickness that you spec'd out on the drawing. Okay, we've got the shoulder pretty well cut. You can see partway up the steering column the fork crown race is just sitting there, and we're just doing a little bit of fine tuning to get that shoulder looking good all the way around. And when we get it to where we want it, that crown race will drop right down. That'll be silver brazed on after we're done fitting it. I don't recommend any other method, actually. I've seen some bikes where they have actually TIG welded this crown race on there. Very bad idea. Do not TIG weld this thing on. Silver brazing is probably the best way to attach it, no matter what type of joining process you're using on the fork. Because of all the sanding and filing we've done around this joint is extremely clean. It's easily clean enough for silver soldering. So we're just going to put the flux right on there without doing any kind of acid cleanup. It's a very clean joint at this point. And we'll put some more flux over the top of it. And then it's a very straightforward joint to do. Sweat that silver right up underneath it, and it pulls it up all the way around. Very easy joint to do. No jigging is necessary for doing this joint. Of course, the crown is fairly thick, so the preheat is going to take a little while. Again, this is silver brazing, so I use my favorite tip, which is an 035 orifice, and I'm using 1/16 diameter, 56% cad-free silver. I'm scooping up my silver, or my flux, every chance I get. Just keep scooping it up when it falls, and keep glopping it back onto the joint. Silver braze these, I actually like to feed the silver up from underneath. Just feed it from below, and the heat will pull it upwards. Every now and then you can add it from the top and bring it down, but it'll tend to roll over the top of that thin area. Incidentally, you can get these pieces, these fork crown races, from whoever you're buying your blades and steering columns from. They also sell the fork crown race. Now we need to cut the crown race press fit, and we're going to use a VAR tool for this. VAR makes 3 of these. They make one for 1-inch diameter steering columns, one for 1.125", which we're using on this one, and they make one for 1.25". Squirt your oil in from down below. Let the oil kind of seep in. This one we use a lot of pressure. Of the 3 major cutting tools we use, the fork crown race cutter has to have the highest amount of pressure on it to get it to work. This cutter also does not get turned backwards. Never turn it backwards. It takes a while to use it. Now that the crown race press fit has been cut, we can pre-assemble this front end, and we can determine with dummy headset how much we want to cut off of this steering column. Of course, if you're doing a threadless steering column, you'll have to have you have to determine it with the particular brand stem you're using, but you'll have to have that amount sticking up beyond the dummy headset for a threadless system. Here we have the steering column mounted in the milling machine vise, and we have a 1/8 inch end mill mounted there, and we've set this for a 25 thousandths depth cut, and we're cutting a keyway for the keyed washer for the headset. This is kind of a hard cut to make because it's considered an interrupted cut, because each time that little tiny cutter hits a thread, it just kind of goes bing, 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 bing as it goes through the threads, and it's very easy to break a small cutter like this. You get down to the very bottom. I don't recommend that you turn around and go in the other direction, because it'll make your slot wider than you want it to be. So when you get down to the bottom of the slot, just stop and remove the fork. And here we're going to use a hogging mill to trim off the end of the steering column and square it up. So we're just passing right past that. It'll square it up quite nicely. And there we go. Nice and square. Mill does leave some cutter marks, and I do like to take a flat file and just quickly take those cutter marks out. Makes it look a little bit more professional, a little more finished. And then, of course, when you get done with this filing, you're going to have a burr around the outside edge. So I just quickly file a 45-degree miter around the outer edges like this. That'll let that nut for the headset start much more easily. We're also going to find that we have a burr around the inside, which could scar your stem when you put your stem in. So use your deburring tool and take that burr out of there. And there's our finished steering column. Now that we have our front triangle and fork completely finished and held together with a dummy headset, we can go and start working on our rear triangle. So let's go over to the rear triangle fixture and start on that. Here's the rear triangle fixture, and you can see that the fork is held in place on the front triangle with the dummy headset, and we're going to level the rear triangle fixture. I've got a digital level there. We're going to get this leveled so that we can if we have a level top tube, we can check to see if it's right. We can also, after the fixture is leveled, we can use a level on the seat tube and the head tube to see if those angles are correct. So we're going to loosen the cylinder back here that the bottom bracket hooks on and move it to the right bottom bracket drop. Incidentally, this fixture, there are plans for a rear end fixture just like this one in the back of my book in the plans for fixtures section. So you can build your own fixture exactly like this, and you don't have to worry about making any mistakes. This is the clamp that holds the seat tube. So we put the seat tube in that clamp, and we can move it around, and the bottom bracket shell is right on that bottom bracket plug, and we'll fasten it back on here. When you have your bottom bracket height set properly, and you have your dummy headset and your fork holding the front end in the right place, everything else should fall into place. This is the front triangle stabilizer bar. And it's made so that you can flip it one way for 1 1/4 inch down tube and flip it the other way for a 1 1/8 inch down tube. Basically what it does is it just brushes against the side of the down tube, and in doing that it keeps the frame tracked properly as it's in the jig. Some people call this a tracking fixture, by the way. When you use a fork and you're mounting in dummy axles like this, a lot of people call it a tracking fixture. This particular setup, you can also have it brush against the top tube. Either way, brush against the down tube or the top tube. Just make sure you flipped it the correct direction for the right diameter tube that you're brushing against. And now we'll tighten up the seat tube clamp, and everything will be pretty well held into place. Now that the fixture has been leveled and everything is securely held in place, we can take our digital level and we can put it on the seat tube, and we can check our seat tube angle, either on the front or the back. Either way works. And if the seat tube is correct, then you can pretty much figure that the head tube will be correct. We do have a problem here in that the head tube is very short on this frame, and it makes it kind of difficult to put any kind of a digital level or an angle finder against that little short head tube. As you may recall on the fork, we had a little bit of a problem with the dropouts not lying flat against the end of the axle, and we've got the same problem here in the back end. So we're going to put that rear dropout in the vise, and we're going to tweak it just a little bit, and then we're going to stick it back in the fixture and tweak it until we can get that dropout to lie flat against the end of that axle. Here we've got the chainstay mitering fixture held in the milling machine vise, and we're checking the distance from the bolt that holds the rear dropout to the bottom bracket miter to get the right distance for the length of the chainstays. This particular mitering fixture holds the chainstays at about a 7-degree angle. So we're going to bolt that dropout with that 3/8 bolt. Hold it carefully into place, dropping it down out of the way of the cutter. We need to make a rough cut. It's easier to make a rough cut rather than have that miter cutter cut on both surfaces. It's better to cut only on one side of the miter cutter, so much easier to cut them on the bandsaw to get a rough cut. All right, now we're going to mount the rough cut chainstay into the chainstay mitering fixture and bolt it at the dropout, and then see I've used a toggle clamp there to hold the larger end of the chainstay in place. I found that with chainstays, since they are rather irregular, it's much easier to eyeball things than it is to actually use the dial gauges to dial in the cut. Eyeballing it in works just as well on something irregularly shaped like this. And as we did with the other tubes, we'll just run that cutter right down. And then when we take this out of the fixture, we can go over to the vise and clean off the burrs. And here we're mounting the other chainstay. You can see it at a little bit different angle here. Maybe be able to see some detail that you couldn't see before. Here we have our final mitered chainstays in place. They're about 5 millimeters from the edges of the bottom bracket faces. And now we're going to start fitting the seat stays in place. There's a little seat stay rest on the rear end jig that holds them in place so they don't fall all over the place. One problem we have with this bike, it's a very small bike, and because it's a very small bike, the dropout tabs aren't pointing exactly toward the seat cluster. So we're just going to trim a tiny bit off the dropout tabs so that when the seat stays are placed on there, things will point toward the seat cluster a little bit better. We're going to do this to both sides. That's a 3-inch diameter abrasive cutoff wheel on a die grinder. Does a very nice job of removing small amounts of metal like this. Here you can see that the seat stays coming off that dropout at a better angle. Now we'll slot the bottom ends of the seat stays to fit over that dropout tab. This is basically exactly the same procedure that we used on the fork blades and the chain stays. Break out those little nubs in there, and we'll use a flat file to get that slot just the right size and shape. As we did with the other dropout joints, we're going to put a little scallop in the end with the 10-inch round file, pretty much for decoration. Also, don't forget to trim out some room or clearance for the sprocket on the inside face of the right seat stay. Deburr it with some emery cloth strips, and then you can do the other side. Now, this is going to be a fat tire bike, and also it's going to be a fastback, and that means that up there where the tire is, right about where the stay rest is sitting, close to my fingers, it's going to be way too narrow for a fat tire. So what we're going to have to do is we're going to have to put a bend in these seat stays. So we're going to put that bend right exactly where we're going to place the bridge. That way any kink that forms from the bend will be covered by the bridge after it's brazed in place. Here you can see the two marks that I've made with a Sharpie marker where the bend is going to be, and that's right about where the tire will be, about 3 centimeters below the bend. Now we're going to set a bevel protractor for a very gentle bend here, 2 or 3 degrees at the very most. You can see just a slight bend there, and that's what I'm going to measure my bend with. All right, right on the mark here, and just a slight bend. And then we'll grab the bevel protractor and we'll check to see how it looks. It might take a couple shots to get it to look good. And then of course we'll bend the other one exactly the opposite direction, the same amount, using the bevel protractor to take a comparative check between the two. And there's our bend, just a very slight bend. It's almost difficult to see. You've got some little bumps of brass around the joint here, around the seat cluster. I'm just going to take a file and quickly clean off any bumps or irregularities which might make it difficult to fit the fastback seat stays in place. I've made a couple marks where I want the rough cut to be, and so we'll cut the tops of these seat stays off at the bandsaw. And now we put the stays in place. Notice they're pointing right through the center of that seat cluster, and I've got them cut off just at the top end there, the top end of the fillet. Pretty tricky fit to do. It's a really irregularly shaped contour, and it takes a lot of trial and error. So park your rear end jig close to the grinder because you're going to be going back and forth several times to get this right. Don't go too fast, don't take too much material, and I usually end up going back and forth between the grinder and checking on the frame as many as 15 or 20 times while I'm fitting these fastback seat stays. Here we have the second side completely fitted. Both stays fit nicely in there, almost no light gaps through there. And then the next thing we have to do is notice that the seat stay doesn't lay flat against the side of the seat cluster, so we need to bend the tab on the dropout a little bit to aim that seat stay toward the seat cluster so it leans up against it in a relaxed state. Now they're setting right up against there very nicely. Nice contoured joint. After that's covered with brass, it'll look really good. Now we're going to mark a spot for an air expansion hole. And I like to vent the holes straight into the seat stays, right through the seat tube. There, right there, that's where our hole's going to be. And of course we'll have another one on this side. And this will have to be kind of a small hole. Probably a 3/16 would be a good size hole to drill. So our drill doesn't wander, we'll just hit it with a center punch to locate that hole. And don't forget that every tube in the frame needs to have 2 air expansion holes or 2 vent holes. So we're going to mark hole positions here about 2 or 3 centimeters up on the seat stays and about 2 or 3 centimeters forward on the chain stays. And I think I'll probably drill about a 7/64 vent hole in these 4 different locations. To mark these holes with an automatic center punch, this one's made by Starrett, and it's a spring-loaded center punch. Actually, more accurately, it's probably a prick punch because it doesn't leave that big of a mark. And it's good to mark your holes with a punch before you drill them so that that drill bit doesn't wander. You can drill these air expansion holes on a drill press, on a milling machine, by hand. The drill press just happens to be pretty handy for me to do it. Since the chain stays and seat stays are kind of irregularly shaped, it's hard to hold them in a vise of any sort. We've got the seat stays and chain stays in place, and I've fluxed the joints back here where the seat stays meet the dropouts with silver brazing flux, and I'll be silver brazing those with 56% CAD-free silver. These upside down, it allows the silver to flow in quite easily. I will finish it up. I'll do some final touches after I pop the frame, the fully brazed frame out of the rear end triangle fixture. But I do most of the brazing here. I always braze this joint first. The seat stays onto the dropouts. If you braze the other end first at the seat cluster, and then you braze down here, and there's a gap, it'll pull your dropout up to meet the gap. So always do these first in case there is any kind of a little gap. Bottom bracket area has been fluxed with Welco number 17 water-soluble brass brazing flux. And this area I'm going to do a couple large tacks on each chainstay because of the backing plate on the rear triangle fixture and because of the base plate on the rear triangle fixture. I don't have a lot of working room down inside there. So just 2 large tacks and I'll finish it off later. Here I'm putting the other 2 tacks on the chain stays. I just finished up with 2 tacks on the bottom sides of the chain stays to the bottom bracket, and now I'm putting on 2 top side tacks between the chain stays and the bottom bracket. Here again, I will not completely finish this joint inside the jig. What I'm going to do is I'm going to put a major tack around the edges of the seat stays where they meet the seat cluster. Notice I've got the plug, the heatsink plug inside the seat tube. That heatsink plug is long enough that it extends all the way through the seat cluster, and that prevents any egg shape problems that may occur, and keeps that opening for the seat post nice and round so that you'll have a minimum of reaming to do afterwards. It's kind of tight quarters here, so you have to move that torch fast so you don't accidentally burn holes into things. The seat tube, since it has the heat sink in it, is quite resistant to heat. So at this time you can point almost directly at the seat tube, and that's going to be your surface to favor with the torch. Careful around those seat stays though. Here we've flipped the frame upside down, and we're tacking on the underside where the seat stays meet the seat cluster. This is a really nice thing about having a fixture that mounts in a park tool stand. It allows the fixture to be flipped upside down quite easily, which is frequently necessary. Now that things are pretty well tacked into place, I've removed the frame from the rear end jig and I've set the fork aside somewhere else. I'm putting in a threaded rod between the dropouts, and I'm also jacking those dropouts apart, probably almost a centimeter more than they need to be, because when I finish that joint in between the chainstays, there'll be a lot of pulling power there, and it'll pull those dropouts together. Here again, the park stand comes in really handy for doing this brazing because it allows us to flip this frame in many different directions. I like to finish around the outside part of the joint where the chainstays are meeting the bottom bracket shelf first. And then after I get done with that, then I go between the chainstays and finish that area in there. The area between the chainstays has an awful lot of pulling power, and it will pull those dropouts together even after the outside surfaces have been finished. The inside surfaces will still pull those dropouts together. This joint takes a long time, and also the seat cluster takes a long time, so it's probably a good idea to take your phone off your hook at this point so that you don't get any interruptions. I do not like to let things cool down. Once I've done my preheat, I like to keep things at that heat until I'm finished so that I don't have to redo the preheat later. You can see I have quite an ample amount of flux on this joint. Here again, if you want to go the extra dollars and buy a gas fluxing system, some of the pros who do production runs really like using a gas fluxer, and they swear by it. So if you have the extra money and you want to spend it, you don't know what to spend it on, go ahead and get a gas fluxer. I would not use money that, if money is tight, I wouldn't spend the money on a gas fluxer just because you think you need one. Notice again my dabbing motion here. When the flame goes up, the rod goes up. I keep the end of the rod and the tip of the flame very close to each other, very close proximity. And again, we will be tilting this frame probably 20 times or more, and always keeping our work area directly on top. Trying to work over the edge or on a vertical surface with brass, you'll just find that your brass is going to flop all over the floor. So keep that little tiny work area, that little tiny puddle, right up on the very top of your work area. You can see as I'm going around this, got to go a little tighter here. You can see as I'm going around this joint, I'm tilting it about every 5 degrees or so, just to keep that little work area right directly on top. I've finished around the outsides of the joint, and now I'm working between the chainstays. This is kind of a tricky area to work because it's hard to blow that excess heat off into midair. And since you're in kind of cramped quarters here, you could easily burn a hole through your either your chainstays or the bottom end of your seat tube. So you have to learn how to blow your excess heat off between the tubes and kind of aim out into the middle of nowhere with that torch flame so that you're not applying heat to an area of the tube that is not going to have any brass attached to it. Also, you have to learn how to use heat control here. If you're running your heat too low, you're probably going to get a lot of pits in your work, little pits that you'll probably have to warm up later and maybe drop some brass into it, or maybe you could drop some silver into those pits. But you need to keep it warm enough so that those pits melt out for you. Also, use an ample amount of flux. If you starve the joint of flux, you'll find that you'll probably have more trouble with those pits. Also, you have to be careful not to start a cavity and build brass over the top of the cavity. If you are starting to build a cavity, shoot your torch flame right down into the center of the cavity and start stirring it around, and jab your brass rod right down into the center of that cavity and fill the cavity up from the bottom out. It's kind of tricky, but once you start building a cavity, you've got to go down inside the cavity to get rid of it. Here we are finishing up at the seat cluster. I'm working between the seat stays. This is a really tight area, and again, you have to make sure that you're not applying heat to areas that will not be getting brass, because those areas, you could easily burn a hole through those areas. And here again, since the plug is in place, you can tend to favor the plug with your flame, and you won't have to worry about burning a hole through the seat tube, because that plug is pulling heat away from the seat tube pretty fast. But be careful around those seat stays. Here again, many changes in the angle to accomplish this. We're going to be changing this angle every 30 seconds to 1 minute. We'll be changing the angle about 5 degrees. There we are. We just spliced another piece of brazing rod together so we don't waste it. Here we've got a pretty good shot of that heatsink plug. You'll notice there's a hole drilled crosswise through the heatsink plug. That'll be used later to stick a Phillips screwdriver or a piece of rod material through there so that we can twist that out of there. Now, after the frame has plenty of time to cool down to room temperature, then it can be soaked in water to soak the flux off. So this flux has been all soaked off, and it's nice and clean and ready for the rough cleanup. Of course, we have a lot of contours, a lot of changing contours around the bottom bracket shell and around the seat cluster, and it's not going to be as easy to do our rough cleanup with a file as we were able to at the head tube. So I like to use a die grinder with an abrasive cutoff wheel mounted in an arbor. Because of the diameter of the cutoff wheel, the surface speed is very high on this, and so a very light touch can be used to remove material. I just go over the whole thing with this cutoff wheel. You have to be careful when you're working with a die grinder. One thing you want to look out for is sparks. Sparks mean that you're cutting into the steel, and so every now and then you'll see a spark here, which means I've hit the steel. But keep in mind, I'm brushing so lightly because of the surface speed of this wheel that when you do see a spark, I'm not taking off very much at all. Another thing you have to keep in mind is when you're using a die grinder to clean these joints like this, you need to go after the high spots. It's the high spots that are the problem. A beginner will tend to go for the low spots because the high spots turn nice and shiny right away, and the high spots look like that things are fine and dandy, and the low spots look like the places where you need to go because they're dull and they're not shiny. But that's exactly the opposite of what you want to do. You want to continue going after the high spots until you meet the low spots. You can see we can get into some pretty tight spots with this abrasive cutoff wheel. That's one little area right there that we won't be able to get completely with the abrasive cutoff wheel, but we can get most of it. Again, we're using the Dynafile with a 1/4-inch belt. Dynafile belts come as narrow as 1/8 inch. I sometimes use the 1/8 inch belts on smaller things, but the 1/4-inch belt seems to be the best size to use for most of these fillet braze joints. Again, the Dynafile is a metal eater. You could do this joint without the Dynafile. You could do it simply with 1-inch wide emery cloth strips, which you could also tear lengthwise and make them into 1/2-inch strips or 1/4-inch strips. But it would take a significantly longer time to do this without a Dynafile. Also keep in mind that there are some air-powered Dynafiles on the market. And there are also some cheaper knockoffs that you can probably get for less than $100 at your local auto supply dealer, and those work quite well also. Very light touch with the Dynafile. The touch here is so light that you probably wouldn't even think that you were removing material if you felt how lightly I was touching. But if you touch too hard, you're going to be taking material away really fast. Also, avoid spending too much time on the steel surfaces. We're trying to remove brass here, not steel. We're trying to take the brass down to the level of the steel. And when you hit the steel, then you're going underneath the level of the steel, and that's when the undercutting occurs. Very, very light touch. I can't emphasize enough how light of a touch I'm taking here. One area that you'll find that on the Dynafile that has a lot of cutting power is that area right behind the wheel, right underneath the head of that wheel. That area, you can also tilt that at different angles and get variations of the radius of the wheel. Right now I'm just going right in there with the wheel, and I'm actually cutting with the wheel, not that span behind the wheel, but I'm actually cutting with the head right now. And as you tilt that head at different angles, you can get different radii to match different contours of the joint. Again, you can see how I'm using the head of the Dynafile. Right there, you can see I'm actually using the head, not the span of the belt. And here again, I'm kind of digging in with the head a little bit. Right there. Look how I'm using the head. Not the span behind the head, but the head itself. And as I did with the other joints, I always like to finish off the Dynafile joints by doing some hand sanding. It just kind of ties things together and smooths out some marks that the Dynafile does leave. Some people would consider the Dynafile tool to be a finishing tool. I prefer not to consider it a finishing tool, and I prefer to do this final hand sanding, and it just cleans things up a whole lot better than just leaving it at the Dynafile stage. I guess if you were doing production runs, commercially made bikes, large volume and so forth, you could probably stop with the Dynafile, and the painter can cover any marks and so forth that the Dynafile may have left. Sanding under the thumb allows you to match a lot of different contours because your thumb is soft. You can put it against any part of the bike, and as you pull that sanding strip underneath your thumb will conform to the contour that you're sanding. And you can take care of just about any shape contour you need to with your thumb. Here we're working on cleaning up the seat cluster. Again, this is a lot of repeat information. This is basically the same procedure as cleaning up the bottom bracket shell. And of course, most of your sanding on the seat cluster can be done with the Dynafile. This will get just about every part of that seat cluster. You will find some little crisscross areas where you flip the Dynafile one way and then you flip it the other way, and you'll miss a little area between flipping, and those areas there, you'll find them on the sides of the seat cluster. You'll find them on the sides of the seat tube down at the bottom bracket shell. Probably best not to even try to get those areas with the Dynafile. You're better off to get those with the sanding under the thumb with the emery cloth strips later. This is the only place on any bicycle frame that I ever use a Dremel tool or a cutter that's as small as a Dremel tool. I really don't like using a cutter this small. They tend to leave some really nasty little marks that have to be sanded out, and it's quite time consuming to sand those marks out. Very light touch here. And of course, when you go in one direction, it tends to dig in. When you go in the other direction, it tends to glide over. So make sure you're not going in the direction where you're digging in. But there really isn't anything that's small enough to get into this tight little spot on a fastback fillet brazed seat cluster. Same as with the other joints, finish up with some under the thumb sanding with your 1-inch wide emery cloth strips. 60 to 80 grit is a pretty good grit to use. You'll get a lot of action with 60 or 80 grit. If you go too fine, 100, 120, you'll be spending a lot of time dragging that sandpaper underneath your thumb. We're going to cut the seat tube off fairly close to the fillet, probably about 1 centimeter above the top edge of the fillet. We're going to be brazing on an Everest seat post clamp here, and so we need to be fairly close to the fillet for this. And after we cut it off, we'll want to square it up, flatten it out with a flat file, make sure that we're nice and squared, like so. And here's our brazed on fitting made by Everest. They make a couple different sizes, so if you want to do an oversized seat tube, say an 1.25 inches, they do make a size for that. And this fits on pretty quickly. Nice fitting, easy to use, easy to install. For fluxing it up, we're using the silver solder flux. This little piece will be silver brazed on. The really nice thing about brazing these fittings on with silver is that the silver melts at such a cooler temperature than the brass. You won't disturb anything in the brass joint when you apply your silver. Same type of preheat here. We're using our 035 orifice on our tip. We're using a long, quiet, carburizing flame, and we're using a 56% cad-free 1/16 silver brazing rod or silver brazing wire. Follow all the other procedures that you did earlier on silver soldering. There's quite a bit more covered on silver soldering in my lugged video. I put all my lug frames together with silver. Notice the scooping action. I'm scooping up flux before it falls on the floor, which is always a problem with any kind of brazing, is that flux falling on the floor. After the piece is firmly attached with a couple large tacks of silver, you may want to turn it upside down. It makes it a little bit easier to do this joint, to feed from the top and draw the silver downward. Here we're going to braze on the noodles on the bottom of the bottom bracket shell for cable guides. And these are little short noodles that have little grooves cut in them, and I find that the grooves make it handy to drop a little counterbalance in them and hold them in place like this. Of course, you want to be careful with your flame so you don't braze your counterbalance to the noodles. One thing, usually you want to make sure everything's clean in silver brazing. However, this counterbalance, it's probably a good idea to leave the counterbalance really dirty. That way the silver will not tend to stick to that counterbalance if you let it get nice and dirty. Here you're going to have to favor the bottom bracket shell with the flame. Apply probably 80 to 90% of your heat to the bottom bracket shell. Those noodles will probably get red. There's no way to really avoid that because they are so tiny. It should take just one drop of silver to hold those things in place. Sometimes I heat up on the inside of the bottom bracket shell and bring the heat outward. That way you can see a little bit better what's going on. Plus you can heat up the bottom bracket a little bit more without heating that noodle yet. Again, a little bit more heat on the bottom side, inside the shell. One problem that happens from heating inside an enclosed area like that, you do get some unburned acetylene that kind of gathers inside those dead spaces, and then it will either tend to blow out your flame for some strange reason, or it could tend to all of a sudden pop and explode on you. Not a big explosion, just kind of a loud pop. And there we are, we're adding the silver. Doesn't take much, just maybe 1 or 2 drops off the end of that rod. We will need an indent on the right-hand chainstay to get some clearance for the smallest sprocket, the smallest chain wheel. And this is a really neat little indenting tool. It was made by Vince Bowden in Golden Valley, Minnesota. I think he made 3 of them, and I got 1 of them. Nice handy little thing, and it just puts a perfect little indentation anywhere you want. And you can lengthen the indentation by moving the tool and indenting again, moving, indenting, moving, indenting. You can put a 3-inch long indentation in with this tool. Here's a little bit better shot of this tool for those of you that would like to make one on your own. Unfortunately, plans for this are not included in my plans for fixtures, but there it is. It's kind of like a clamp that's on a V-block. Here we've taken a piece of chainstay and we're fashioning a bridge for between the chainstays. This is a piece of chainstay from a road bike, so it's round. And we're fashioning a bridge for between the chainstays. Fits right in there. That'll be fillet brazed in later. Looks like a good fit. The next thing has to be done is that little bridge will need air expansion holes, and so we're going to mark for an air expansion hole. We'll use a Starrett center punch again to mark for this air expansion hole. Very handy tool, and it makes just a big enough of a mark for a very small hole, like 1/8 of an inch. There we go. It's spring loaded and it leaves a mark. Here's a close-up of that automatic center punch tool. And let's drill this one on the drill press. You can see that we're putting a pretty small hole in there. Looks like probably a 7/64 or a 1/8 inch. Handy to drill it with the vise. It keeps it from rotating. There are V-shaped grooves in the jaws of that vise that hold that piece quite nicely. We're going to switch to a 1/4 inch hole. We ran that 1/8 inch hole all the way through both sides of the bridge. Now we're going to run a 1/4 inch hole through one side, and that will allow us to put a water bottle fitting in the back side of that bridge so that we can mount a fender later. And there we go, 1/4 inch through 1/2. And there's our bridge, all fitted and drilled with air expansion holes. One thing I like to do to hold the bridge in place while I'm brazing is I like to use a bridge jack. And a bridge jack is pretty easy to make. Here it is. We're threading in a threaded rod between the dropouts, and we're also jacking those dropouts a little bit apart, because when the bridge cools after it's brazed in, it will tend to pull the dropouts together. And now I'm taking and turning that nut on my bridge jack so that the jack holds the bridge tightly into the area. And there's a good shot of the bridge jack. And we're using Welco number 17 brass brazing flux here. This bridge will be brass brazed into place. We're going to kind of do some micro fillet work here, and we'll clean those micro fillets up pretty much the same way we cleaned up the other major fillets on the bike. And the style will match the rest of the bike quite nicely. This is pretty much the same procedure on this bridge as it is on the rest of the bike. I have dropped down in torch size. I'm using an 035 torch tip on this, which is my preferred tip for silver brazing, but because the fillets are so small, I'm going to use an 035 on these little tiny brass fillets. Notice I've removed the bridge, but the threaded rod is going to stay between the dropouts through this whole process. You can see that we're in some pretty tight quarters here. Obviously, we wouldn't want to use that larger tip in doing this type of work. Again, we have to tilt a number of times while we're doing this joint. Joints on the chainstay bridge are left to cool. We can start working on the seat stay bridge. I usually use a piece of half-inch chromoly steel aircraft tubing for seat stay bridge material. Half-inch by 035 wall. That's a good thickness to use. You can also use a piece of a seat stay. The tops of the seat stays that we cut off earlier in the video. Pick one of those up off the floor and start mitering it and using it as bridge material. And here we have a nice fit, about the same distance from the tire as the chainstay bridge was. Another thing we're going to have to do is we're going to have to put air expansion holes in here. I'll put one air expansion hole on the underside, a 1/4 inch in the middle, and we'll put a water bottle fitting in there later to hold a fender in place. And then I'm going to put two little 7/64 air expansion holes, one at each end of the bridge. All three holes will face down, so they'll be out of sight from the customer. Again, we'll use the Starrett center punch to mark our three holes. There's a vent hole. Here's for that 1/4 inch hole in the middle. And here's for another vent hole. We'll drill these on the drill press as well. We'll drill them first with a 7/64, all three holes with a 7/64, and the center hole will be later taken up to a 1/4 inch. And there we go. Here again we have our bridge jack in place, holding the bridge tight into the area. And don't forget, this bridge has been cut just the right length, so it's going to be covering up those dimples where we put the bend in the seat stays. I'm putting on Welco number 17 brass brazing flux right now, and we'll be doing some micro fillet work on this one the same way we did on the chainstay joints. And you can see there's the bridge jack in place. The threaded rod has never been taken out from between the dropouts yet. Cleanup on these two bridges will be by hand. There won't be any dynaphile work done here. We're just in too tight a quarters down there to risk bringing the head of that dynaphile in contact with other parts of the frame. So this will be all done by hand filing, and the final sanding as well will be done by hand, by sanding underneath my thumb with the emery cloth strips. Was done earlier. The object here is to remove all the high spots, any bumps or whatever that are in the fillets that we brazed on here. And also we want to make sure that we're removing little or no steel while we're doing this cleanup. Said earlier, no dynaphiling here. This is all going to be sanded by hand. The seat stay bridge, this will be all finished by hand. My favorite file to use for these really small fillets is a 10-inch round file. Some people call it a rat tail file. 10-inch round file matches the radii that you need to file and matches the contours of these small fillets quite nicely.